So take down a problem. Find the energy of x of t. So x of t is given to be a into e power minus alpha t into u of t. Okay. So this is, you have to find energy of this signal x of t, which is a into e power minus alpha t into u of t. Okay, where alpha is greater than 0. So how do you plot this? You have x of t, okay, and you have u of t here. What is this? It is unit step signal, right? So unit step signal is it's a continuous time unit step signal. So u of t, by the definition of u of t, we know that it exists from 0 up to infinity with an amplitude 1, right? So it is 1 for t greater than or equal to 0. It is 0 for otherwise or t less than 0. Okay, for negative values of t, it is 0. Only it's positive. It's 1 only from 0 to up to infinity. Okay, so we'll try to plot this. So at t is equal to 0, what happens to this waveform? X of t is equal to a into e power minus 0, right? Which is nothing but a into e power 0, which is nothing but a. So at t is equal to 0, you have signal at a. So at t is, if x of t is equal to a into e power minus t is equal to 1. So if you have e power minus 1, so a into e power minus 1 will be a value which is less than a. Okay. Similarly, at t is equal to 2, x of t is equal to a into e power minus 2, which is nothing but it's a value less than a. Okay. So you get a signal something like this. So this is a non-periodic in nature. Okay. So we are finding the energy of the signal. So E is equal to, what is the equation for energy of a signal? What is the equation for energy? It's minus infinity to infinity x of t square into dt. But in our question we have find the energy of x of t, which is nothing but a into e power minus alpha t into u of t. So u of t is a signal which exists from 0 up to infinity. So what happens to the integral? The limits change from 0 up to infinity, correct? So t is equal to 0 up to infinity. You have a into e power minus alpha t into u of t. We'll take u of t as 1 whole square into dt. So try solving this. What do you get? So we have integral 0 to infinity a square into e power minus 2 alpha t into 1 into dt, right? So a is a constant. I'll take a square outside. Okay, so you have integral 0 to infinity e power minus 2 alpha t into dt. So what is integration of e power minus at? Integration of e power minus at is nothing but e power minus at by minus a, right? So what do you get solving this? So you have a square into, if you integrate e power minus 2 alpha t, you have e power minus 2 alpha t divided by minus 2 alpha, right? With respect to this, if you integrate e power minus at with respect to 0 to, from a 0 to infinity, you get e power minus at by minus a with limit 0 to infinity. Okay, so you have e power minus 2 alpha t by minus 2 alpha with limits 0 to infinity. So now we'll take a square by minus 2 alpha. Okay, so and we'll substitute the limits for t. Okay, first we'll substitute upper limit as infinity and lower limit as 0. So you have e power minus infinity minus e power 0. What is e power minus infinity?
0, ma'am.
It is 0, right? So e power minus infinity is 0 and e power 0 is, what is e power
1.
0? 1. So you have a square by minus 2 alpha into 0 minus 1. So what do you get? Energy
A square by 2 alpha.
a square by 2 alpha joules. Okay, so that is about energy of exponential. Okay, e power minus at into u of t, or e power minus alpha t into u of t. Okay, so we shall see some periodic signals now. So we have seen enough energy signals, so we shall see some of the periodic signals. So find the power of x of t, which is equal to a cos omega naught t plus phi. So what type of signal is this? Cosine signal is a periodic signal, right? So this is a cosine waveform with a phase shift of phi. Okay, so we have to find the power of x of t. So what is the equation for power for continuous time signals?
Excuse
E is
me, ma'am.
equal, yeah,
Ma'am, it is A cos what is in the bracket, ma'am? W.
omega naught t plus phi. A cos omega naught t plus phi.
Okay, ma'am.
Phi is a phase shift. Okay. So what is the equation for power for periodic signals? It's 1 by t integral with respect to t. You have x of t square into dt, right? So what is our x of t? It is a cos omega naught t plus phi. So substitute that. So we have period 1 by t integral 0 to t. Okay. So we have a square cos square omega naught t plus phi into dt. So you have cos square theta. So how can you write this cos square theta? It's in cos square theta form, right? So cos square theta would be 1 plus cos 2 theta by 2. Correct? So write it in this form. What do you get? What is theta here? Theta is equal to omega naught t plus phi. Okay. So what do you get? So a square is a constant. I'll take it outside. A square by t integral 0 to t. So how do I write this? 1 plus cos 2 omega naught t plus, it's phi or 2 phi? 2 phi, because our theta is omega naught t plus phi. So 2 theta would be 2 omega naught t plus 2 phi. Okay. So it is 1 plus cos 2 omega naught t plus 2 phi divided by 2. Correct? So I'll take this 2 to the other side in next step. So have a square 2t. So if you integrate 0 to t naught with respect to 1 into dt plus 0 to t naught, I'll split that. So you have cos 2 omega naught t plus 2 phi. So what do you get if you integrate this? If you integrate cosine, what do you get?
Sine.
I am not able to hear you.
Ma'am, why you have replaced t by t naught, ma'am?
Okay, just it's t. So we have t, yeah. So what is integration of cos over entire period t? What do you get? What is integration? Integration is basically, it's an area bounded by the curve, right? So if I plot this cosine waveform, just a minute, whiteboard is hanging. So if I plot this signal, so cosine wave will be something like this, right? So if I take one period, so it will be from here to here. This is your t. So what is this area and this area? So this we have cosine, we have cos theta, cos signal over one period. So we know what is integration, it's area bounded by the curve, right? So addition, we have positive area, this is positive area and this is negative area. Okay. So addition of these two areas will nullify the area present. So what is integration of cosine over the entire period? So what is integration of cos? So area is nullified here, right? This is positive area which is equal to negative area. If you add these two, you'll get this, right? Addition of these two will give this, right? So it will nullify the area, right? Yes or no?
Yes, ma'am.
So what do you get? Integration of over cos, cosine, what do you get? So integration of cosine over entire period, what do you get? So area is getting nullified here. So what happens here?
Sine, ma'am.
It will become 0, right? You can also solve for sine and you'll get 0 only. But I'm teaching you some trick that if you integrate a cosine signal over entire period, it will be 0. Okay, so this whole thing would be 0. Fine. So now we are left with a square by 2t with limits 0 to t 1 into dt. So integration of 1 is t, as you people know. So we have a square by 2t. If you integrate 1, you get t with limits 0 to t. So what do you get? A square by 2t to t minus 0, which is nothing but a square by 2 watts. This is the power of cosine signal. Got it?
Yes, ma'am.
Followed? Clear, everyone? So we have to find the power of periodic signals. Okay, we find energy of aperiodic signals. So cosine wave is a periodic signal, so we find power. So they have given you to find power. You can directly go ahead and find a power of this continuous time cosine wave. So the equation for this is P is equal to 1 by T integral over entire period x of t square into dt. So our x of t is a cos omega naught t plus phi. Okay, cosine wave with a phase shift of phi. So we have 1 by t 0 to t integral 0 to t a square cos square omega naught t plus 5 into dt. So this cos square theta I can write it as 1 plus cos 2 theta by 2. So it's nothing but a square by t integral 0 to t 1 plus cos 2 omega naught t plus 2 phi by 2. So be careful here. So you have cos square theta. Okay, your theta is omega naught t plus phi. So here you have cos 2 theta. So 2 theta means 2 omega naught t plus 2 phi. Okay. So if I take this 2 here outside, a square by 2t integral 0 to t 1 into dt, I split this 1 into dt plus 0 integral 0 to t cos 2 omega naught t plus 2 phi. Okay. So integration of cosine over an entire period is 0 because integration is nothing but area bounded by the curve. If we try to plot this cosine, so what will be the area? You have positive area and negative area. So it will get nullified here. So integration of cosine will be 0, okay, or entire period t. So that term will become 0. So we have a square by 2t integral 0 to t 1 into dt. So integral of 1 is t. So substitute the upper limit and lower limit. So you get a square by 2 watts. Clear everyone? Is it clear guys?
Yes, ma'am.
So take down next problem. X of n is equal to minus 0.5 to the power of n into u of n. Okay, try plotting this. You know what is u of n, right? What is u of n? It is unit step signal in discrete form. Okay. So what is the definition of u of n?
Which has same amplitude after t equal to 0, ma'am.
N here, okay, because it's discrete signal, n will come into picture. Okay, t will not come into picture. T will be coming to picture only in continuous time signal. This is discrete time signal. So this your x-axis is n here. Okay, so u of n is nothing but 1. It is 1 for n less than. Sorry, for n greater than or equal to 0, it is 0 for n less than 0. Okay, so you have 1 amplitude of 1 for n is equal to 0, 1, 2, 3, 4, 5, so on up to infinity. Fine. So you have u of n into minus 0.5 to the power of n. So what is minus 0.5 to the power of n? How will it look? So we have understood that our signal x of n will exist from 0 up to infinity. That means if you have u of n multiplied with any function, that means your signal is existing from 0 up to infinity. Okay, it is not present for negative values of n, it's present only for positive values of n. Okay, if you have u of n or u of t in your question. So now we have to plot this signal x of n is equal to minus 0.5 to the power of n. So how do you plot this? So this is x of n which is equal to minus 0.5 to the power of n into u of n.
Ma'am, by taking n values positive, ma'am.
Yeah, you have to substitute the value of n and you have to plot. Okay. So now we'll try plotting this. Yeah, at n is equal to 0, what you get? X of 0. So n is equal to 0, which is nothing but x of 0, which is equal to minus 0.5 to the power of 0. What is this?
1, ma'am.
1. At n is equal to 0, your signal will be at 1. Okay, at n is equal to 1, x of 1 would be minus 0.5 to the power of 1. So what is this?
1, ma'am.
Minus half, right? Minus 0.5. How you get 1?
My first one is minus 1, ma'am.
Minus 0.5 to the power of 0. It's 1, right? How minus 1?
Ma'am, in calc it's showing minus 1 only, ma'am.
Ma'am, it's 1 only, ma'am.
It's 1, right? Minus 0.5 to the power of 0. It's 1. Okay, minus 0.5 to the power of 1 is minus 0.5. Okay, so at 1, n is equal to 1, you have minus 0.5. At n is equal to 2, what you have? You have minus 0.5 to the power of 2. So what is that?
1, ma'am.
Minus 0.5 to the power of 2. How you will have 1? For all you are telling 1, 1.
0.25.
0.25, right? At n is equal to 2, you will have plus 0.25. Okay, at n is equal to 3, what you have? X of 3 is minus 0.5 to the power of 3. What do you have now?
Minus 0.125.
Okay, minus 0.125. Okay, so as you can see, the signal is diminishing signal. Okay, so at n is equal to infinity, it will become 0. Okay, the signal will go to 0. So we have to find energy of the signal. So try finding energy of the signal. So you have to know how the signal looks graphically. So we have plotted this. Okay, now try to find energy of the signal. What is the equation for energy of discrete time signal? You have summation n is equal to minus infinity to infinity x of n modulus of x of n whole square, right? So E is equal to, what is the summation limits? N is equal to
0 to infinity.
0 to
How
infinity
to
because
find
you have,
energy or power, ma'am?
we have to find energy. Is it periodic? No, right? It's
And for
non-periodic.
non-periodic, the power also you can find, no, ma'am.
See, I'll tell you for non-periodic, the difference between that is, for a non-periodic signal, if your amplitude is converging, see amplitude converges here, right? Still
Yes,
people
ma'am.
are joining. So you have to understand, it's only I have sent you that links. I think you didn't go through that links. So all the bounded periodic signals are power signals. Okay, because they don't converge to finite values. What is bounded periodic signal means? What is the meaning of bounded? Which is existing between minus infinity to infinity. Okay, bounded periodic signals are power signals and they don't converge to finite value. Okay, but what about these? They're converging to finite value, right?
Yes, ma'am.
So this is energy signal. Okay, so I'll explain you after I do this problem. Okay, so bounded periodic signals are power signals. Okay, periodic signals are power signals. Bounded means which are in the range of minus infinity to infinity, and they don't converge. Okay, they don't converge to a finite value. So their energy will be infinite and power will be finite. Okay, these are power signals or periodic signals. I'll tell you the difference at the end. Okay, now you understood this one. This is converging, so it's energy signal. So bounded periodic signals don't converge to finite values. We shall see such problem also. Okay, now you can see, you can try solving this about, yeah. So we have summation limits n is equal to, you have u of n in the problem. So u of n is a signal which exists from 0 up to infinity. The summation limits would be 0 up to infinity. So it will start at 0 and end at infinity. So what is our x of n? It's minus 0.5 to the power of n into u of n. U of n is 1. Amplitude is 1, right? So we have to square that. So if you solve this, what do you get? Try solving this. try to get it in the form of geometric progression and solve it. So E is equal to summation n is equal to 0 up to infinity. So you have minus 0.5 to the power of 2 to the power of n. Okay. So I'll write 0.25 to the power of n. Okay. Summation n is equal to 0 to infinity. I'll write 0.25 to the power of n. So we have got this in the form of geometric progression, right? Summation n is equal to 0 to infinity. Alpha to the power of n is 1 by 1 minus alpha. So our alpha is 0.25. So if you, what is your energy now? What is the energy? Energy is nothing but we have alpha, we have this is in the form of GP, right? So your alpha is nothing but 0.25. So energy is nothing but 1 by 1 minus 0.25, which is nothing but 4 by 3 joules. Okay. So I'll explain you once again. We have some more problems to solve. Yeah, I'll brief up once and we'll start with one problem. Because you're still in dilemma about energy signals and power signals. So first I'll tell you what is a power signal. Okay, we can say a signal is a power signal if its power is finite and energy is infinite. Okay, so we tell a signal is a power signal if its power is finite and it's non-zero and its energy is infinite. Okay, similarly we'll tell energy, we tell a signal is an energy signal if its energy is finite and non-zero, whereas power is 0. Okay, so I have told you periodic signals are power signals. Okay, periodic signals are power signals, whereas non-periodic signals are energy signals. So you have a dilemma that whereas non-periodic signals also we find power for non-periodic signals also. So why do we solve, why do we calculate power for non-periodic signals also? You had a question, right? So we'll see that. So all the bounded signal, as I told you, what are bounded signals? Bounded periodic signals. So all the bounded periodic signals are power signals. Okay, they don't converge to a finite value. Fine, they don't converge to finite value. So what happens here? Energy is equal to infinity and power is finite. Did you follow? Periodic signals are power signals because they don't converge to finite value. They'll be going up to infinity. Okay. So coming to energy of power signals, it will be infinite. So energy of these power signals would be infinite. Okay. So you can tell best examples of these periodic signal are sine or cosine or some wave like this. Okay, which goes on from minus infinity to infinity. These are all power signals. Okay. So these sinusoidal signals or cosine or periodic signals have non-zero power, but they have infinite energy. Energy is infinite. Okay. A signal can be either either it can be a power signal or energy signal. It cannot be both energy signal and power signal. Okay. So I have told you periodic signals are power and non-periodic signals are energy signals. Okay. So what is the best example of non-periodic power signal is, there is an exception case. Okay. So non-periodic signal you'll find power only to one exceptional case signal, that is unit step signal. Okay. So non-periodic power signal best example is unit step signal. Okay. So here unit step u of t is something like this, right? It exists from 0 up to infinity, t is equal to 0 to infinity with amplitude 1. Okay, this is a non-periodic power signal. Okay, so it doesn't converge to a finite value, right? It doesn't converge to finite value. So energy of this signal is infinite. Energy is infinite and power is finite. Fine. Did you follow? So power signals don't converge to a finite value, but energy signal will converge to a finite value. Clear now? Energy signals are non-periodic. They converge to a finite value. Whereas periodic signals are power signals, they don't converge to a finite value. Okay, whereas energy is infinite here and power is finite. Clear?
Ma'am, at above also you have written non-periodic power signal, no ma'am?
This is non-periodic power signal.
Down you have written energy as power, non-periodic signal, no ma'am, again.
Yeah, energy signals are non-periodic signals, but power signals might be periodic or non-periodic is only one exceptional case, that is unit step. Clear?
Okay, ma'am.
So energy signals are non-periodic. Okay, for non-periodic signals we'll find energy only. Okay, whereas for periodic we find power. So there is one non-periodic power signal, that is nothing but unit step signal. Clear? Followed? Is it clear? Yes or no?
Yes, ma'am.
So we'll continue the problems. Okay, you try solving this problem. We'll verify the answers in our next class. So I have some more problems on energy and power signals. Okay, you try this as homework problem. I'll solve it in tomorrow's class. X of n is equal to 2 power n into u of minus n. Okay, so you analyze the signal and you find energy and power of the signal. Okay, next.
Ma'am, when power signal you are given formula for period non-periodic for that when we should use, no?
Power non-periodic. When you're having unit step signal, you have to use.
Only for unit step.
Yes. This is exceptional case. Okay, non-periodic power signal is unit step signal
In formula
exceptional
you are
case.
given x of t and x of n. Instead of that you should write u of n and u of t.
Where?
In formula, my first class.
Which formula?
Power signal.
Yeah, power signal formula.
You are given for power signal non-periodic.
Yeah. Have given power signal non-periodic. Have given x of t and x of n, continuous and discrete.
Limit t tends to infinity 1 by t minus t by t to t by 2 x of t the whole square into dt.
That is power for
No, non-periodic.
power for non-periodic, yeah, limit I have given t tends to infinity, 1 by t minus t by 2 to t by 2, x
X
of
of t
t
the whole.
square into dt. Yeah, this is for continuous time non-periodic.
Yes, ma'am. When should we use this one?
When you
Only
have
for
u
unit.
of t, unit step, u of t. Okay,
Yes, ma'am. This is applicable only to unit steps.
unit step. Exceptional cases, unit step. I told you all periodic signals are power signals and non-periodic signals are energy signals. So when you have non-periodic power signal, then use this one. Power. This is for power. Power for non-periodic continuous time signal. And also I have given you one more formula, right? For periodic signal. Yeah, period. Have given for discrete, that is u of n, right? So power for discrete time signal is limit n tends to infinity, 1 by 2n plus 1, summation of n is equal to minus n to n x of n square. This is for discrete time non-periodic. I'll solve problems on this, okay? These two I'll solve it. Fine.
Yes, ma'am.
Vinamrata, your ma'am is taking class now? Microcontrollers?
Yes, ma'am.
Okay, fine.
Ma'am, also Vijaya ma'am wanted a little bit time from your class tomorrow. Like you can take from 8 to 9:30 continuously, and then from 9:30 till 11 o'clock she will take like from your class also a little time, and you can take from her class half of the time.
I didn't understand. Tomorrow you want me to take class at 8 to
Ma-
9:30.
Yes, ma'am. Like 8 to 9:30, and from 9:30 she'll take till the break. Is it fine for you, ma'am?
But I had class at 9:50, no?
Yes,
9:50
ma'am.
to
In the
10:40.
between, in the from 8:55 to 9:50 is her class, ma'am. So she wants you to take the half an hour, and she wants continuous like one like another like from your class half an hour.
Today also she took, right? Today also mom took my class.
Yes, ma'am. That's what she wanted to take. She's asking. That's why, ma'am. Saturday morning you can take 1 hour for the compensation, ma'am.
So tomorrow from 8 to 9:30 you want me to take.
1.5 hour, ma'am.
Okay, 8 to 9:30. Fine.
Okay, ma'am.
Ma'am, one doubt, ma'am. These formulas, whatever you explained, like power signal, energy, like we discussed it in last class, ma'am.
Yeah.
Ma'am, I had connection problem. I didn't attend like the later part of the class. That's all.
Okay, you listen to the recordings. If you
Yes.
have any doubts, you can contact me.
Okay, thank you.
Okay. Yeah, so you start solving problems, okay? So you can start solving problems from local authors, or you can use that Simon Hekin only. And we have discussed about from beginning we have discussed about even and odd signals, periodic, non-periodic signals, okay? And we have solved problems on that also. Now we are discussing about energy and power signals, okay? So energy and power, I need one more class to complete energy and power signals to get clear understanding to you. And I am also left with discrete time even and odd signals. I'll do that in tomorrow's class. Tomorrow I'll complete of energy, power, and even and odd. From next we can do operation on signals. Okay, that would be very interesting. Okay, guys, we can wind up this session.
Ma'am, local author in the sense Ganesh Rao, right?
Satish Tunga Ganesh Rao is one book, and Uday Kumar is one more book. You can refer. You can buy. You can take any one of those.
Okay, fine.
Okay. If you want me to send PDF of those textbooks, also I'll send you for Unit 1.
Yes, ma'am. It would be better, ma'am, if you would.
Okay, I'll try to make PDF and send you.
Okay. Thank you, ma'am.
Yeah. Thank you, students.
Thank you, ma'am.